So good evening.
Good evening, Father Brinkman.
Leave it to the guys to give you support. I'd like to welcome to our Redemptorist community Dmitry Kousnetsov, who is one of the foremost Shroud experts in the world right now, but he asked me not to say anything about his work. So I won't steal a second of his thunder on that, just to welcome him here among us. And what he asked me to do is just to give a little background as to what the Holy Shroud is. And what I thought I would do is just give a little history of it, where we think it's been, the years that it's been in existence. So, of course, at the present moment, it is enshrined in the Savoy Chapel in Turin, part of the Archduchy of Savoy in northern Italy. And the ownership of the Holy Shroud is divided between the Cardinal Archbishop of Turin, the House of Savoy, and the Vatican. And in 2 years, there's going to be a very important anniversary of the Holy Shroud. In 1898 was the first photograph taken by Pio II. And they were simply wrapping it up and wanted a couple photographs of the Holy Shroud taken. And when he took the pictures, remarkably, an image appeared that looked something like this. The Holy Shroud, naturally speaking, looks like this, with a light background, with a very faint image, a very faint shadow-like image. And this is more high relief than you would actually see if you saw the shroud. It's very delicate. It's dark, slightly darker brown on brown. And when he developed the face area, it came out looking like a positive. So what they thought they had for many, many years is something like a photographic negative that no one could ever explain. It's just when the negative was developed, it looked so striking that they immediately interpreted this as a photographic negative, and what they were looking at was a negative image. And it's certainly true when you look at the whole shroud in the negative, which it does look like a positive image, very faint, of course, but a positive image. It was in this Chapel of Savoy since the early 16th century, since the early 1500s. Before that, it was somewhere in southern France, and the places changed between Livray and the areas, suburban areas around Nice, France. And it belonged to a Crusader family named Geoffrey de Charnay. And there were two Geoffrey de Charnay. They distinguished them as Geoffrey de Charnay and Geoffrey de Charny. The one was a Crusader, and when he got back from the Crusades, along with many of the Crusaders, they burned them at the stake for idolatry. This would have been in the 1200s. A couple generations later, a Geoffrey de Charny emerged. They have no historical records there's any connection between the two families, but the similarities in the names are striking. And Geoffrey de Charny is the first owner of the Holy Shroud in the West. He started displaying it in the chapel that he had in his aristocratic royal family. And in fact, the bishop complained that he was displaying an idolatrous image, and Pope Clement VII, I think it was, wrote to Geoffrey and told him not to display this idolatrous image without having seen it. Before that, what they think happened to it was that it was kept in Constantinople and that it was seized by the Crusaders and brought to the West. It had been in Constantinople since around 600, 700, 800. The history is very indefinite. Before it was in Constantinople, they think it was in a little town in Asia Minor named Odessa, which, if you looked at the map of Israel, Odessa would be way up here where Turkey would be, in southern Turkey. And it went there within a generation or two after the death of Christ starting in Jerusalem. They think it was taken from Jerusalem to Odessa, to this king Abskar, who was a Turkish king who became a Christian early on. They have some records of him around 200 AD. And they think that it was, he was the first one to enshrine the Holy Shroud. And of course, they didn't want to display the whole thing. Of course, you see an image of a naked person. They had reverence for the the body of Christ in such a way that they thought it would be improper to display the whole thing. So they had it wrapped up in such a way that all you would see is the face. So there are evidence of folds on the Holy Shroud that would indicate the way it was kept through history, folded up, and just the head being displayed, and that would be kept in a case, and the face displayed in an oval manner. So one of the interpretations of the Holy Shroud is that it has always reflected the history of the Church during the theological controversies of the early centuries. The Church Fathers, they disguised the body of Christ and just had the divinity, you might say, displayed in the face. As the scientific community became more active in the Enlightenment, the Renaissance, more of the shroud got exposed. During the Reformation, the church was torn apart, and it was in 1531 that there was a terrible fire where the shroud was being kept, and that's where some of these patches, you'll see these patches that are on the shroud, they were sewn by the Sisters of Charity around 1535 to disguise or to support the material that was burned away. When the silver reliquary melted, of course it was folded in such a way that one corner was burned that went through the whole cloth, so that you had these little patches that were sewn on to keep the material together. And there are other markings on the shroud. There's watermarks, like here, down here, where they tried to put out the fire, where there would be damage from water. There was also other fire damages, like in these little holes in the cloth right here. You don't see the holes in the cloth because there's a backing to the shroud. There's a piece of cloth behind the thing that always keeps it supported. And during some of the testing, they would look underneath of the shroud to see what was under there. So I don't want to say too much about all of this because Dmitri will enlighten us on many of these things. But this is the cloth that we believe has traveled through history. In the carbon-14 testing, what they seemed to prove was that it was a medieval forgery, prove in quotes, because they found a lot of paint on the shroud. So they did find pigments on the shroud, and they think those that support the existence of the shroud as a relic of Christ would say that paint got on there from the medieval times when they would have the custom of making third-class relics. So someone would paint a representation of the Holy Shroud. Then sometimes while it was still wet, they would touch it to the actual shroud to make it a third-class relic. And so that's how they think some of the pigments that they find on it got there. But on the image itself, you find no brush strokes. The depth of the image area is less than the thickness of a human hair. When they held the shroud up to light, shine light through it, and the image area just goes away. It's so thin, this image area. It resembles a scorch. It resembles some sort of celluloid oxidation that happened very quickly, very fast. There's some very remarkable things about the image that just can't be explained or can't be duplicated by modern science. So, since I said the words modern science, I'll give you Dmitri and let him take it from there.
Thank you, Father Brinkman. It's a great pleasure to be here. If you have any problems with my English, please feel free to interrupt me, asking questions. But I will try to be as understandable as I can. First of all, following Father Brinkman's explanations, I would like to note that in the tradition of Eastern Church, in the Russian Orthodox, Bulgarian, Serbian, Greek, Coptic Orthodox churches, in liturgical tradition, there is a very special element, and this element is a shroud. For example, in certain kinds of cases, the Russian Orthodox priests celebrate the Eucharist on a table covered by the cloth with the image of Christ on it. And moreover, in the liturgical tradition, that particular piece of cloth called officially as a shroud. So, plus if you would try to investigate some peculiarities of Asian icons, especially those icons which were created in 4th, 5th and 6th centuries in Byzantine Empire, in island of Cyprus and in certain Egyptian areas, you will probably find a great similarity or homology between the face image of the man of the shroud and those icons. And this similarity is very, very impressive. And not even being an expert in iconography, my specialty is chemistry. I'd just like to mention that intriguing fact. And because of very well-known political events which allowed us to travel, to exchange ideas and stuff like that, now I guess is a good time to exchange cultural traditions and some sort of historical information from both East and West in terms of the Shroud of Turin to complete the whole picture we have by now about the Shroud. Now, before 1991, I had no even a chance to hear or to read something about the Shroud of Turin. Even now, in 1995, there is no one single book on the Shroud of Turin in the Russian language so far. And certainly, a couple of years ago, the situation with availability of any information about the Shroud for Russian public were much worse than we have now. My specialty is biopolymer chemistry, and I used to work for a long time for forensic chemical institution in Russia, and even now I'm working in a lab for some forensic purposes. I'm a head of a small private laboratory which has a lot of orders from Moscow Police Department in particular for some kinds of chemical analysis. But starting with 1990, we have been involved in a certain kind of archaeological chemistry analysis as well. And at the end of 1991, I attended a small conference in London, England, on the radiochemical or radiocarbon dating method. And my report has been devoted specifically or particularly to accuracy, to efficiency and accuracy of the radiocarbon dating in archaeology. On that time we had enough reasons for skepticism about the accuracy of radiocarbon method in general. Radiocarbon method is a very good method. In fact, we still do not have better for archaeological purposes. But as well as any other scientific method, radiocarbon method is not ideal, is not panacea, and this method obviously has limitations. And you could expect correct conclusions from this method only in case if you would be able to take into account those limitations, of course. So we delivered a report about radiocarbon method expressing our skepticism. We collected many references from world available literature, published in many languages, including English, of course, first of all, from which we accepted that kind of skepticism. And basically, a radiocarbon method provides probability, but not certainty. And now let me tell you how most archaeologists work with radiocarbon method before 1988 and after 1988. First, they dated the object historically and stylistically, taking into account a complex historical context of the particular site, like historical records, like stone graves, signatures, like some cultural levels and strata in that site, stuff like this. And finally, they, archaeologists I mean, coming to a conclusion about how old is this particular object. And then, to be precise, to make sure to clarify the conclusion, they ordered radiocarbon result. Then, if then a radiocarbon result fits the whole stuff of evidences that they had before, they remain it. If not, they reject it. Before and after 1988, the most prominent archaeologists in the world, and first of all Israeli ones, used and still using radiocarbon method like additional method for clarification of those conclusions they already had by analysis of historical and statistical details. Which amazed me a lot is a very famous publication in Canadian Journal of Forensic Chemistry published in 1968. And the first radiocarbon approach has been introduced to the scientific community in the mid-50s. So some people collected shells, living shells, mollusks from Atlantic Ocean, living ones. Then they homogenized the shell into powder material and then sent it to Rochester, New York, for radiocarbon facility with a question, how old is this object? And the radiocarbon facility gave an answer that it is 2,000 years old, but it's still alive. So that's actually not too funny, it's a problem of accuracy and probability. But that kind of errors happens from time to time. And the radiocarbon method applied to the Shroud of Turin is really, even superficially looking, far from ideal. First of all, the piece of cloth which has been separated from the shroud for that particular analysis has been chosen in one particular place, not in different places. And that place is very close, located nearby the burned site, which has been damaged during the fire and carbonized perhaps. Then there are some suspicions that those labs which were on charge of radiocarbon dating knew in advance what the sample is all about, that they knew that it was a shroud. There are some indirect evidence that in reality this experiment was not blind. And like as Father Brinkman said, the appearance of the Shroud of Turin in the Western Europe has been dated to a mid-13th century or 14th century, depends on historical evidences. So in 1988, a large international team of experts in radiocarbon dating and museum science and from 3 laboratories from Zurich, Switzerland, Oxford, UK, and Tucson, Arizona, published their report in a worldwide circulated magazine, Nature, with the conclusion that this is a Middle Ages forgery. They dated this relic to 14th century. And like they said, with a 95% confidence. Now, I am not an expert in the radiocarbon dating. And I'm not an expert in the Shroud of Turin either. I'm a chemist. And I do some archaeological work in my lab with physicists and computer scientists. And those radiocarbon dating itself, we ordered. We did many things ourselves, but as for radiocarbon analysis, we ordered that analysis in Arizona, here, and in Protvino in Russia. And when I said we, I mean we contacted Arizona lab through participation of our friend from Italy, Mario Maroni, perhaps you know. So in 1991, soon after my report about the skepticism on the accuracy of radiocarbon dating in archaeology, I've been approached by a gentleman from France whose name is Guy de Bertot. This is a member of CIELT, French group, specifically designed, almost like Hollow Shroud Guild here in America, for purpose to collect and analyze any information, scientific information concerning the Shroud of Turin. Monsieur Bertot did express his interest in our studies. We invited him to come to see us in Moscow. He came. And since then he visited our lab at least 11 times in the recent 3.5 years. He gave us money and order for first step of our studies. He gave us a simple question, simple for him, not for us. And the question was, is it possible or not to prove experimentally in the laboratory a probability of the change of radiocarbon content in the linen cloth as a result of fire, and if yes, if that changes are capable enough to make a serious impact on radiocarbon dating calculations. So, in 1532, a very significant event had happened in a cathedral where Shroud of Turin was kept in a French city, Chambéry. The long-term fire was happening, and the monks did all they can to protect the shroud by a very simple way: to pour water on a silver reliquary where the shroud has been kept for a while during this time. From the historical records, we know how long was this fire. We know geometry of this box reliquary, which gave us enough ideas to calculate concentration of combustion gases, carbon oxide and monoxide in it. We know temperature too, because the Shroud of Turin has been damaged by melted silver. And Allen and Heller, American scientists, back in 1978, estimated a dramatically increased content of silver in certain areas of the shroud damaged by the fire. So we know temperature of melting of silver, which means we know temperature of incubation. Plus, the silver is a very well-known chemical catalyzer, which is accelerator of all possible chemical reactions. And after all, linen cloth itself contains of cellulose. All linen textiles contains of at least 95 or more % of cellulose. And cellulose is a very well-known long polymer molecule. And chemical structure of this molecule is that they this molecule is very capable to participate in almost possible kinds of chemical reactions. So what we did, we gave historical description of this fire to two independent teams of fire defense experts in France and Russia, with a request for suggestions. What exactly conditions, physical chemical conditions of the fire should we remain constant in our experiments in the lab to imitate, to simulate that particular historical fire? And they both gave us very similar, almost identical recommendations. Then we have obtained a very special sample of linen cloth, which has been given to us through Mario Moroni by Israel antiquity authorities from Israel. This cloth has been excavated in En-Gedi site, Israel, and dated historically to early Roman period, which is about 2,000 years before present. And morphologically, microscopically, the method of weaving of this cloth very similar to the Shroud of Turin. And of course we had a lot of modern, up-to-date, manufactured linen stuff too. We incubated this stuff in our special conditions, computerized chamber, computerized compartment with a constant temperature, combustion gases, water, silver concentration for a certain time. And before and after this experiment, of course after very extensive washing of linen to remove all possible mechanical contaminations, we have studied the chemical structure and isotopic content in the cloth. So far, is it understandable for you or not? Any questions?
Maybe the linen actually comes from flax, right?
Yes.
That's the plant.
Yes.
Just as a...
Yes. Why a radiocarbon method is capable to date anything? Because radiocarbon is a clock. Okay? That is a number of radiocarbon atoms, and that is time. And the law of decay is exponential or logarithmic. Okay? So, let's say this is 100 atoms, and this is 50 atoms. The time during which a 50% of given amount of atoms will disappear or decay, called half-life period. And for radiocarbon, it's equal to 5,740 years. That law does not depend on pressure, concentration, or temperature, which is good. Now, if you have any object which comes from living organisms, like from flax, and if you would be able to measure a content of radiocarbon atoms in it, like here, for example, you can extrapolate that measurement to a scale of time into the past, so you will know the age of this relic. Living flax, like all living creatures, absorbs carbon-14 from atmosphere with a carbon dioxide gas. And carbon-14 comes to carbon dioxide from nitrogen-15 as a nuclear reaction. But as soon as the organism died, the assimilation process stopped, and only decay will remain. That's why it's possible to use it for dating. But of course it's more or less a rough method anyway. Now let's go to our stuff. Well, okay, could you give me a remote control of that or what? Okay. Now, okay. All right.
Can you flip the switch in the back as well? All the way to the top. There we go.
No, no, no.
There you go.
Okay. Now let me entertain you. First of all, and I would like to make it perfectly clear, I do not have any problem to being wrong. And I would never claim that a theory we came with is 100% true. And as you can see from my previous explanations, we had no chance even to touch the shroud itself. We're just playing with some other stuff to re-evaluate the dating of the Shroud of Turin. So those conclusions we had about 3 years ago, for example, now seems to us old and they need to be rethinked. So science is a developing knowledge, and that's why I would never say that this is a final step in our search of truth. Okay, this is just a main building of Moscow State University, which is the largest university in Europe, 67,000 students. That particular building has been erected in the 50s under Stalin government, and this is a very huge, green and beautiful campus. And I graduated from this school. This is the main entrance into the university, and this monument is a statue for founder of the school, academician Michael Lomonosov, who founded that university 350 years ago, roughly, which is not very old by European standards. That is the main entrance to the school, just to give you some imagination about it. Okay, this is this person, not very, can you take care of focus, please? I think it's not very clear. No.
Yes.
Okay.
That's pretty good.
Okay. Okay, this is Dr. Ivanov. He defended his. This picture has been taken 2 years ago, or 2.5 years ago. Currently, he has a PhD in nuclear physics. On that time, he was on the way to this. That's me, my secretary, and this is Monsieur Bertot, if you remember him from Rome, Father.
Yes.
This is a person who gave us the first grant for Shroud research, and that is his second or third visit to our lab. Excuse me. And this is historical moment. We're saying this is, I would say, it's historical. To me, it's historical. We signing a paper, an agreement for a grant for 1 year long research program in Moscow. You can see snow from the window. It's a beautiful Russian winter. He came from warm Paris, being absolutely undressed, and it's my wife loaned him my coat, and if you can see the difference between me and him, you understand what kind of problem that he has. Alright. Did he have? Okay, and that is a scheme, a general scheme of experiment. I already explained you in non-technical terms. Just very, very briefly, I would pay your attention to that particular stuff. And by the way, if somebody of you is chemist or physicist, and if you would have any technical questions, you could ask them after I will finish. But now I'm trying to be non-technical in my explanations, to be understandable for a lay person. So, we took a textile, no matter what, old or in some cases old, in some cases modern, then we cleaned this textile very, very extensively. Those 3 labs in 80s, they has a perfect procedure of washing of textile, including acids, alkali, detergents, organic solvents, heating, and that particular method is absolutely enough to remove all possible mechanical contaminants from the surface of the fibers. And that's why, in particular, I disagree with some of my colleagues, like Dr. Gassa-Valdez, for example, who trying to prove a mechanical coating of the fibers on the shroud. I know perfectly that the method of washing of the shroud, which has been employed in 80s and which has been employed in our work, is absolutely enough to remove everything which is not chemical bound to the cloth. All mechanical contaminants should be removed. After incubation in our fire compartment, again we have washing extensively of the fibers, then we isolated fibers, then we analyzed chemical structure somehow, this method called capillary electrophoresis in mass spectrometry. And of course, too, we analyzed radiocarbon dating by sending all those samples to radiocarbon facility in Protvino, Russia. And now, the next slide. Okay, I'm sorry. Oh, this. Okay. Even before dating, we analyzed infrared light reflected from the surface of linen before and after fire simulation. Control for solid line means intact linen without or before fire. And punctuated line means experiment, in other words, after fire. We have great difference. And all chemists understand the difference. This is a reaction called carboxylation. This is a chemical introducing chemical incorporation, not mechanical, chemical incorporation of extra carbon from atmosphere as a portion of carboxy group into the cellulose. That peak stands for carbon dioxide, and that difference stands for dehydration for the removal of water from the textile structure. This is a rough but good enough illustration, and further illustration is better. I mean, not so rough and more precise.